Hello, this is Justin Self, and I am going to go over problem 7.2. It's for physics 323 optics. So the question says two harmonic light waves with amplitudes of 1.6 and 2.8 interfere at some point P. All right, harmonic is good because that means that we can use those wave equations that we're used to using. Awesome. Here are the amplitudes. I'm going to assume that these are in volts per meters. Great. We'll just assume that so we can plug it in. Okay, what visibility results if their electric field vectors are parallel, and B if they're perpendicular? Well, I'm going to start with B real quick. If the if the electric field vectors are perpendicular, there's no fringes, so there's no interference. No fringes, therefore interference. Okay, that's an easy one. You can see that with the dot product. Now we are going to see that here. Check it out. So now if their electric field vectors are parallel, okay, that's going to give us an actual answer here. So the equation for visibility, I'm going to conveniently pull it up here, is this guy here. And there it is. If you're using the Pedrati textbook, this is equation 717 on page 168. Cool. So that's visibility, which gives us, they call it fringe contrast. It's useful, and it's going to be a number between 0 and 1. Cool. So we need to find Imax and Imin to run this thing. So again, I'm going to get in here and find my equations. Oh, look, I just happen to have them right here. So again, you can find these in your textbook. Imax is given to be I1 plus I2 plus 2 times the square root of I1 times I2. These are the equations and location in the book. And each intensity is given by this equation here. Now I want to show you something here. Check it out. This is why it doesn't work for the other one, for the perpendicular fields. And this is why it will work for parallel fields. This is when you take the dot product inside here, if these two fields are parallel, you'll get it basically results in the magnitude. The dot product of two parallel fields, two parallel vectors, gives you the magnitude of that vector squared. And so I'm just going to write that as E squared. If they're perpendicular, you'll end up getting 0. So that explains why that would work. Okay, cool. Hopefully that helps. So we're going to use this 1.6 and 2.8 value. We're going to calculate this thing. So what we need to do simply is calculate the I values for each one of those two amplitudes, plug them into these, and then plug it into the visibility equation. So I will do that real quick for you. All right, so I1 is equal to 1/2 epsilon naught times c, the speed of light, times E1 squared. Recall that E1, magnitude of E1, is equal to, I believe, 1.6, and the magnitude of E2 is equal to 2.8. All right, c is the speed of light in a vacuum, 3 times 10 to the 8 meters per second, and epsilon naught is 8.854 times 10 to the minus 12, and I'm not even gonna deal with the units on that one. But suffice to say that the units here are gonna end up in watts per meter squared. All right, cool. So that's going to end up being 1/2 times epsilon naught times c times 1.6 squared, which gives us a value of 0.0034 watts per meter squared. Great. And similarly, I2 is equal to 1/2 epsilon naught c times E2 squared. Okay, and recall that I'm just going to take a shortcut here. E2 is 2.8, so I'm just going to write 2.8 squared like that. And then that is going to end up, we'll type it into our calculator, and that will give us, let's see, 0.010412 watts per meter squared. I am kind of blasting through the units here. I do recommend that you do it at least once. Run it through with all the units written out for all this stuff. I'm not going to take the time to do it here, but man, you've got crazy units here. You've got meters per second here. We've got watts or volts per meters and then squared here. And so you've got to do a little bit of trickery to get the units to work out. Not that bad, but you will end up with watts per meter squared if you do it right. Okay, so now we've got I1 and I2. And recall here, we need to do I max and I min, so we can plug them into this equation here. So I max is I1 plus I2. So we're just gonna plug that into our calculator. I'll just type it in here. I max is equal to I1 plus I2 plus 2 times the square root of both of them. Okay, and when you type that into your calculator, using the values that we just found, you get I max is equal to, you should get 0.025712 watts per meter squared. And likewise, if you do I min, you will get the same way, I1 plus I2 minus, notice that the only difference between these two, by the way, is just you minus that second term for the min and you add it for the max. Right? So type that in and you should get 0.001912 watts per meter squared. All right, great. Okay, now we type it into visibility, which is equal to I max minus I min all over the sum of those two. Okay, I'm not going to bore you with the details, but you know how to use your calculator. So you type it in and you will end up getting 0.86. I'll just leave it at 1.5. And there are no units here, okay, because you've got the same units on top and on bottom. And so that should be the answer. Cool, pretty straightforward. Hopefully that was helpful. Thank you for watching.